Right, we're going to carry on with this paper. But before we start, look at the composition of air. So you've got 78% nitrogen, 21% oxygen, 0. Well, almost 1%, 0.9% argon, and then finally you've got CO2, which is 0.04%. You'll need to know that for your sciences anyway, especially chemistry. Right, they've said the percentage of oxygen in the air is 21%, which is equivalent to 21 and then 4 zeros parts per million, so 210,000 parts per million. Right, what you can do is, so look, this is how they've done that, 21%. Now, how did they turn this denominator into a million? So how did they do that? Let me just do that. 1, 2, 3, there you go. Right, so they've multiplied it by 10,000. So I'm going to multiply the top number by 10,000. So 1, 2, 3, 4. That's how they've converted it. Now let's do the same thing for that. Yeah, so we start with 0.04%. And they've multiplied it by 10,000. That's what they've done, yeah. They multiplied it by 10,000. So that will become 400 parts per 1, 2, 3, 4, 5, 6. So it's 400 parts per million. So parts per million, 400. That's probably the easiest way to do it. Right, so remember it's not parts per 100, but it's parts per million. So somehow we've got to get the denominator up to a million. Right, okay, so here you've got right, let's have a look. What factors affect photosynthesis? Yeah, so they've said CO2 levels, temperature, so you've got light intensity, temperature, CO2 levels. These are what you will come across as limiting factors. These are what you call limiting factors. Right, okay, that's that done. Let's crack on with this. Right, the graph shows the effect of increasing the concentration of CO2. So concentration of CO2, as that increases, the relative rate of photosynthesis goes up. And have you noticed, let's use that one. There's 5 degrees and there's 35 degrees. So the rate of photosynthesis goes up as temperature goes up. And then it'll get to a point where it'll stop having an effect. Right. Describe the effect of increasing the concentration of CO2 on the relative photosynthesis at 5 degrees. So if you notice, as the concentration increases from 0.04, 0.06, 0.08, 0.1, the relative photosynthesis is going up, but it's gradually leveling out, and eventually if everything goes there, it'll just flatten out. So it doesn't matter how much extra carbon dioxide you add, it will not affect the rate of photosynthesis. So then that's one of the limiting factors. So the up to that point, it's a limiting factor. Beyond that, it doesn't matter how much CO2 you throw out, it's not going to improve the rate of photosynthesis. So now we need to describe that for 2 marks. So we can say increasing CO2 levels increases rate of photosynthesis. Then it begins to level off. Right, okay, that's what will happen. Let me just get rid of that so it's a bit easier. Did I just press that? Right, okay, let's just get rid of that. So if you notice, look, it's steeper here. Ooh. The gradient's steeper here and it's less steep there. Right, and then it's even less steeper there, and then eventually it will level off. Right, so it'll reach a maximum. Right, describe how the effect of increasing concentration how the effect of increasing concentration of CO2 on the relative photosynthesis changes when temperature is increased. So what they're trying to say is describe it. We're not going to explain it, we're going to describe it. So let's go up. So have you noticed that this has got the highest curve, steepest curve, and then it slowly starts leveling off, and then that might level off way over here somewhere at a really high. So if you extended this, it might start leveling off at a really high percentage concentration. So CO2 for plant photosynthesis will be good if you're looking as a farmer for yields. So remember the word yield. Right, so we can say the steepest curve, or the highest rate of photosynthesis is at 35 degrees Celsius. Yeah. Increasing CO2 for 35 degrees, increasing CO2 increasing CO2 for all temperatures increases the rate of photosynthesis. So for all of them, photosynthesis. CO2 so if you look here, now we're constantly, let's get rid of all that. Let me just get rid of all this. So if you look where they all meet down here, oh come on, they all meet down here, right? So it's gonna be just about 0.03. So about 0.03%, right? The temperature has no effect. So the adding CO2 will not make any difference at this. So CO2 is the limiting factor there. So we can add that. So that's just one more observation, but it's only a 2 marker, so we can just add this. So at CO2 level of 0.03%, the temperature is not a limiting factor. Yeah, and then you'd have to increase the temperature. You'd have to increase the temperature and the CO2. So whatever. You'd have to increase the temperature here. You see these are higher temperature, and increase the concentration levels for things to really pick up and to take advantage. All right, explain this and explain. The first and most obvious thing is as temperature increases, so does the relative rate of photosynthesis. Okay. Now, what's the next thing we need to look at? Right. What's the explanation? Right. This is because the molecules have more kinetic energy, right? And then again it goes down the standard route, so you have more successful collisions per unit time. So this is a standard answer. Basically what they're saying is, look, I want these two molecules to hit each other to form a product. Right, first of all, if they're traveling faster, they're more likely to hit each other more often. Secondly, they'll be traveling faster, so you'll be above the activation energy. So there's two things going on. It's quicker and they've got more energy, so your rate of reaction is going to go up. And this is what this line means. So just learn that and just throw it in. Right. Right. Where are we? So if we look at this, so what's going to happen is this is going to level off first. Well, it's almost leveled off. So 5 degrees is really your temperature. So we can say temperature becomes a limiting factor. So increasing, so what they're trying to say is, and this is what you need to know is, if you add more CO2, it will be wasted. They're not going to take advantage of that. It's like having, if you want to compare it to something, it's like having a plate of food, right? With loads of food on, right? And a person's eating it. Once they're full, just say they've eaten that, they've eaten that, they've eaten that, they've eaten that, they've eaten that. It's no good giving them a plate with 1, 2, 3, 4, 5, 6, 7, 8, 9, and then adding, just say a few more. It's not going to help. It's not going to help at all. So this is how you've got to look at it. Right. Scientists carried out study concluded increase in CO2 is dependent on the temperature and also, right, minerals that the plant can absorb. So it was temperature, CO2, and minerals. Explain how lacking a named mineral might affect. Right, the two, remember what we said about minerals? The one I always go for is magnesium and nitrate. Magnesium. What's going on there? Yeah, magnesium is for chlorophyll. It's used to make chlorophyll in the chloroplast, right? The other one that is good to know is nitrate for amino acids for growth of the plant, for nuclei or nucleus is a DNA. So what will happen is you're going to end up with yellow leaves instead of green leaves, which are going to start a reduce photosynthesis. This is going to reduce growth because you won't have enough material to make DNA. Okay. Explain how the named factor can affect the rate of photosynthesis other than CO2 temperature. Right, so what did we say about yeah, okay. We said CO2, temperature and light. Yeah. Now they've also introduced minerals, so but just let's look at light. Light increase will allow more photosynthesis to take place. Right, so more of the chloroplast can absorb and make food for the plant. Right, another one that you might want to consider is don't use white light, use only certain types of light which it absorbs. So use different colored or wavelength of light because with white light some is not absorbed, that's wasted then. The most obvious one apart from just say light is water, because water is used for photosynthesis. Water is used during photosynthesis. Right, okay, so that's question 8 done. Let's have a look. Right, what we'll do is we will do this in the next video, I think so.